Demo is going to be about how to run a moderation model when your moderator is a dichotomous variable or a categorical variable. This is the same example in the lab from the lab. We are trying to predict GPA based on ADHD score, and we are trying to see if that relationship is moderated by social problem or someone who has social problems versus someone who does not. So clearly social problem is our moderator. GPA are DV and ADHD score are IV. Before we go about conducting that analysis, we need to think about a few things. First off, our moderator, since it's a categorical variable, we need to make sure that it is dummy coded. If it is more than 2 levels, we need to make sure that we have created dummy codes for all the contrasts or comparisons that we want to run. And in this case, we actually only have 2 categories. So we have social problems, which is coded as 0, and no social problem is coded as 1. So we already have that taken care of in this data. Second thing we need to do is center our IV. That will help us create that interaction variable, which we can then look at the effect of. So at this point, ADHD score is not centered. For us to center it, we need to know what the mean score is, and then we can actually compute a variable that is centered ADHD score. So we will just run descriptives on ADHD score, which is going to give us our mean value. Now 52.6023 is our mean value. It is advisable to use as many decimal points as you can. In this case, SPSS table is displaying 4, but when I double click on it, it actually gives me more decimal points. So I am going to copy down that number, because when I copy from here, it's not going to copy the whole thing. So anyway, so I have a 52.602273, which I am going to use to center my variable. So I'm going to go to transform, and I am computing a variable. So I am going to compute a variable, center ADHD. You can name it whatever helps you remember it whenever you look at the data later on. So, and this is ADHD score, subtract the mean from it, 52.602273, and that's all you want. So I know that my center variable has been computed, and now that I have my center variable, I want to create an interaction term between that centered IV and the moderator variable, and that is going to help me figure out if the relationship between ADHD score and centered ADHD score and GPA actually depends on social problem variable. So I'm going to go to compute again, and then this time I am creating a variable that is actually a cross product of centered ADHD and social problems. So I can name it whatever I want as long as it tells me what it's doing. So centered ADHD times social problem, and now we have a variable that is our interaction term. So once we have all of this taken care of, we are going to run our regression, which is going to be sequential regression, because we want to not only look at direct effects of our IV and moderator, but also we want to figure out if adding an interaction would actually help us in our prediction. So thinking of that logic, we would run a sequential or hierarchical regression. So our dependent variable here is GPA. Our independent variables for this one, we will add ADHD score, and we will also add social problems, and then we will hit next, and for blocks 2 we are going to add our interaction term. We can also add both of these variables that we had in block 1 It just means the same thing, that we're adding just one more additional variables. And if we add identical variables in block 2, it's still interpreting the uniqueness that is because of this new variable. So that is that. And then for statistics, I am going to just click all the values that I've looked at in sequential regression. Sometimes you can look at part and partial correlation. The reason is, especially when you talk about part and partial correlation, it is looking at the unique variance added because of the new model, which is kind of R squared change that SPSS is calculating. So it's just looking at the same thing, but you can this is where you would get that information. So yeah, so I'm not going to click it because the table itself is going to give me R squared change, so I don't need my additional calculation or correlations. So I'm going to hit continue. I'm not interested in plots right now or other options, so I am just going to hit OK. So this is, and you're familiar with this kind of output because you've done sequential regression in the past. So we are just going to get to our point rather than going through all the tables. So model summary table, it gives you the details of 2 models that we ran. So the first model had social problem and centered ADHD. Second model, we introduced additional variable of our interaction term. Now, if you look at the F change, you see that first model significantly predicted our GPA. With second model, with additional interaction term, there was a change in, there was a significant difference. So when you see that your model 2 or model with your interaction is significant, then everything else that you interpret from ANOVA table and coefficients table is going to come from model 2 block. If, however, if this is not significant, then you would actually report statistics from ANOVA table from model 1 and coefficients from model 1. Because basically it's telling us that interaction wasn't significant, so we're not interested in the model that includes that. We would, however, report that we looked at it and then it didn't come out to be significant. So in that case, you would report these statistics, but then you would report everything else from model 1. So in this case, our interaction term actually is significant. So there is an interaction going on, which means that relationship between ADHD scores and GPA depend on social problems, or someone who has social problems versus someone who doesn't. Looking at coefficients, you know how to report coefficients for a continuous variable. So for example, ADHD, it shows that with 1 point increase in ADHD score, GPA is actually going down by 0.054 points. So there is a negative and significant relationship between these 2 variables. The social problems, however, it's not significant, but if you were to find this relationship significant, you would interpret not that as you would interpret a continuous variable, but you would think of it as this value represents the mean difference between the 2 groups that we have. One group that is coded 0 and the other is coded 1. So in this case, social problem is coded 0, no social problem is coded 1. So a positive value here tells you that whatever level you have coded as 1 had the higher mean. So in this case, someone with no social problems actually had a higher GPA of 0.135 points higher than someone who had social problems. And again, it is not significant, but if it were, that's how you would report it. However, even though we don't see a direct relationship of social problems on GPA score, we do see that social problems and ADHD actually come out to be significant, and this is the same significance value here. So this is, again, telling you exactly the same thing, that relationship between ADHD and GPA depend on social problems. Now, this is telling us, again, if you think about how we were reading interactions in ANOVA, our overall table was giving us that there is something going on. But in order for us to figure out exactly how means are different and things like that, you had to just investigate further. So when it comes to regression, you would actually do some additional steps in figuring out exactly that relationship of that interaction. So I am going to shift to the lab notes now, so because it's going to be easier for me to show you there, but I'm just going to go through it quickly. So you would start with a regression equation and then converting that regression equation to a separate regression equation for group that is coded 0 and then group that is coded 1. So all you're doing is just replacing wherever we have our coefficient for the for that categorical variable to either 0 or 1. So this is what we're doing, and this gives us here it gives us equation for group that is coded 0, equation for group that is coded 1. And the next step you would do is you would take the values from a regression table, regression coefficient table in model 2, and then put those values in these equations to get a specific predicted equation for those. So this is, I just copied the values from SPSS table here. So once you put them in the regression equation, you would get overall regression, predicted regression equation, equation for someone with social problems. So basically, if you interpret it, this is telling you that for high school students with social problems, because that is coded 0, there is a slight negative relationship, which is represented by negative 0.054 between ADHD score and GPA. So yeah, and this is also I think this is in the regression table as well. Yeah, for the separate regression equation for students with no social problems, which is coded as 1, you would get this equation or predicted equation, which tells you that for high school students without social problems, there was a weaker relationship. So this beta is negative 0.010, which is smaller than this one. And you can then take a look at that, use these specific equations, and then at least get 2 points for each of the ones to plot them in SPSS. So we took that equation for social problems that is coded 0, and then we got the predicted GPA value if ADHD was 0 or ADHD was 10. So remember, the 0 and 10 are just 2 data points that we have picked up. As long as 2 data points that are within the range of score of ADHD, we can pick that. Remember, we can also pick negative 10 because we centered the variable, so we would have range of values and negative score as well. So as long as we have that in the range of ADHD variable, we can pick any 2 values. I picked the easiest ones because those would be very easy to calculate, especially if I'm doing it by hand. So I picked 0 and 10 for ADHD when social problems is coded as 0. And then I did the same thing with my second equation. I got my predicted GPA when ADHD is 0 and 10. And this gave me these 4 values that I can then plot using Excel. I can also create a chart in my hand on the paper and pencil. So basically, looking at that is just trying to interpret the interaction that we have done in the past. So for high school students with social problems, there was a slight negative relationship between ADHD score and GPA, whereas for high school students without social problems, there is a weaker relationship. and then you're just comparing the slopes as we have done in the past. And you would include this information in the write-up as well. So if you look at the write-up here, since our model 2 was significant, or interaction was adding something significant to the model, we are reporting all of these statistics with interaction term included. So regression model with ADHD score, social problems, and interaction. If it was not significant, we would have just reported the two main effects and how that model 2 was significant. Then we get into the interaction. It is a little bit different than when we talk about ANOVA. We had our main effects first and then our interaction, because most of the time when you're running interaction, that is what you're mainly interested in, but you can just switch the order here as well. So we're talking about the interaction and then how it is adding something extra to the model. So we're reporting R square and then F statistics as well. And so these are all F change values and P change value here. And then this information is actually coming from the chart that you plotted, so all the extra work you did, you would just talk about that information here. And then this is basically the main effects that we're talking about. And then at the end you would give a summary, and then we're also giving out a table, which is most of the journals also request that kind of information. So basically, this is how you would run a moderation model. Remember to think about dummy coding variables, think about centering your IVs, and also creating an interaction term before you regress everything, before you regress your DB on all of the variables, including your interaction term. So this is it. I know this is a little bit of manual work, but it's going to be a good practice for our next lab when we talk about how to run a moderation model when you have a continuous moderator instead. All right, hope this is helpful. Thank you.